In our last section, let's just summarize all the transformations and what's going on. And over here, this little diagram goes over each transformation here, the main ones. This is also kind of just a general form for the equation. It could be a x squared or an absolute value or a square root or any function, but you're looking for the a, the h, the k, and they have different roles there. So I'll just kind of run through these here real quick, then we'll try some examples out. Basically, if your a value is negative, that's going to reflect it over the x-axis. The A has a second job. If it's bigger than 1, then we would call that a vertical stretch. We're talking about dilations over here. If that value is between 0 and 1, like 1/2 or 3/4 or 0.1, then it'd be a vertical compression. Your H value here with the X would move it left and right. It's always the opposite of what the sign would be. And K is probably the nicest thing. That moves the graph up or down. What you see is what you get. A couple others, these are to be the main ones I need to test you guys on. Just others to be familiar with would be, let's see, get rid of this, would be this guy right here. If there's a B in front of the X, if there's a value in front of this X, we'll call it B, just like an A value. In this situation here, if that B value is negative, then it's a reflect over the Y-axis. So if you have a negative on the outside, that reflects over the X-axis. If you have a negative directly on your X inside a group, then it reflects over the Y-axis. If that number next to the X right here inside the grouping symbols is bigger than 1, then we have a horizontal compression. And if that number is between 0 and 1, then it's a horizontal stretch. So it's kind of like opposite. Kind of everything inside the parentheses is opposite of what you would think. Like if it's negative, it actually moves in the positive direction. If it's a bigger number, it's actually compressing it towards the y-axis there. So a little bit different. These are good to be aware of if there's a number next to the X, but it's much more common to see vertical stretches and compressions. Like here, we've got this absolute value graph that we want to do. They graph the parent function. They went ahead and graphed the other one too, but and we could do that as well. But we want to figure out all the transformations by looking at the graph, looking at the equation. And the goal here would be, could we just figure out from the equation? First, there's a negative on the outside, so it's going to reflect it over the x-axis. There's a 2/3 here on the outside, so that's going to compress it vertically. Vertical compression. The 3 here, it's opposite, so it's a positive, so it actually moves in the negative direction to the left. And what you see is what you get. It moves it up 1 unit. So that's what's going on here. It's been, this V shape has been flipped, moved to the left, up 1, and then it's kind of a little bit wider than this other graph. Feel free to pause to try these other ones out. There's going to be a few curveballs here, but here's what we got. First up, be careful. When we have a number on the X, we know there's going to be some sort of horizontal something. In this case, it's bigger, so it's going to be a horizontal compression. The other thing is, though, it's not exactly moved right 3. We have to look at just the X and this number together. So what I did here is I took away the 5. I essentially divided by 5 or undistributed the 5, leaving with X minus 3/5. If I distribute, I'd be right back to this. But I'm trying to get in this format so I can see what numbers really added or subtracted to the X. That takes care of my horizontal shift left and right. So in this case, it's actually only moved right 3/5. The 5 here is just fine. That moves it up 5. Similar problem on this. First, there's a negative on the outside, so it's going to reflect over the x-axis. I got to rewrite this, so we're going to do, so it is a horizontal stretch. It's horizontal because it's attached to the x there, and it's a smaller number, so it's actually stretching it. If you rewrite it, I forgot to rewrite it over here. If you rewrite it, we take away the 1/7 from the x. It would also mean I take 1 and divide by 1/7, which actually makes it bigger, makes it 7. I can distribute, be right back where I started. So it didn't move left 1, it actually moved left 7. Down 4 from the -4 over here. This one here is definitely one way to interpret it. It reflected over the x-axis because of the negative sign outside there, and it's a vertical stretch, and it's moved up 1. Because it is a line here, you could describe this other ways that we could discuss in class because they're so simple. These guys here are usually a little bit easier to actually interpret, but a negative lines, we could have said it's also reflected over the y-axis, for example, and this could have been like a horizontal compression. We could go to get into all that. There's multiple ways to describe it. We got a vertical compression. We got a smaller number here, a negative on the x. So again, that's going to tell me I'm going to have to rewrite some stuff. So take away the negative from the x, which makes it x minus 5. So negative on the x means reflects over the y-axis, and we actually end up with a right 5 movement. Here's a little word problem. So like just looking at this crazy equation, like we could try to graph it, but like let's even just kind of visualize it without having to go to like a graphing calculator or Desmos or something. We know we got all these values. A is negative 0.125, H is 12, K is 18. So we know it's moved 12 units to the right and 18 units up. We know it's compressed vertically, and it's got a reflection because of the negative sign there. So we know all the transformations. And really what's going to happen here is it's going to be a x squared as a parabola. It's reflected, so it's going to open downwards. It's moved, the vertex is moved to the right and up. So this is my vertex right here, and that's really where our maximum height is. If this models the path of the dolphin, then this is the maximum height. So we got a parabola that opens down. The max height here is of 18 feet, 12 feet from where he started. So we like basically jumped out 12 feet and 18 feet high. This here is kind of similar idea. Can we apply some transformations, understand what's going on here? Probably overly complicated, but we've got this cx equals 4.5 plus 0.32x. X here is our weight in ounces and so on, and we're trying to interpret what's going on here. First, the positive 4.5 means it's moved up 4.5 because it's unattached. We could rewrite it as 0.32x plus 4.5. The 0.32 is a smaller number, so it's a vertical compression. Basically what's going on here is we got this fixed cost. If you're going to buy a salad, there's a fixed cost of 4.5. You have to pay that no matter what. Even if I got 0, I'd still have to pay 4.5. I don't know if it weighed 0 ounces, still have to pay something. The 32 cents here is the changing cost of 32 cents per ounce. All right, we could also come up with an equation from a graph. So we're just gonna like notice some things like, okay, it's a V shape, so it's absolute value. We have a general format. It looks a little wider, like it's been compressed. So I'm gonna assume there's some sort of vertical compression. And that A would be positive because it opens up. It does not look like it's been reflected. So in this case, it's moved left and down. So I know H and K would both be less than 0. They'd have to be negatives. In this case, it's moved 3 to the left. So we'd say a -3 or -3, and down 4, so -4. You can even put those in the equation. Minus a negative does become a +3. So that's why it's always the opposite of the sign when it's inside with the X. The only thing I'm missing is the A value. Like, what is this value? So what you can do is pick a point. We could pick any point. I usually pick something besides the vertex. And so I could pick this point and plug it in. That's my X value of 0. That's my Y value of -3. And the only thing left now is that value of A that I want to solve for. So let's see what we get. 0 plus 3 is still 3. The absolute value of 3 would just be +3 still. If you add the 4 over, you would get 1. And then divide by 3, you get 1/3. So putting it all together, going back to this step here, we know that we got an A value of 1/3, which does confirm that it has a vertical compression that's a little bit like wider going here. And there's my whole equation. Again, feel free to try that on your own here. Feel free to pause, give these a try, come back. The trick is to kind of set up with what you know, and then go back and solve for that A value by plugging in a point. Try to pick something other than your vertex, like maybe this point here, this nice y-intercept. Okay. You should get this answer and this answer over here. Notice this one here is just moved to the right, did not move up or down, so there's nothing over here. If you're not sure how to get that A value of -1 here or this A value of 2, let's talk about it in class, and we'll see what we can do from there.